Enable rồi. No, wait, that one. This one, right? Yeah. Wow. This snapshot. Man, I use Loom.
Sorry guys, we were experiencing a little bit of technical difficulty
Yeah.
with QuickTime.
This one.
Yesterday there was no sound, right?
Yes, it wasn't.
Okay, I make sure to enable my microphone. Where the heck is this?
I'm using more complicated than mine, man.
Why is it not screen?
I think it's recording the whole screen, man. I'm pretty sure I see this outline right here. Go, man. Okay.
When I click this, it's take a snapshot.
But look, it's recording right there.
Oh, what the heck?
That's what I'm trying to tell you. Go.
Okay, let's go. Okay, guys, so we are gonna review what we have done yesterday. First is before this week, we already know how to make a website with HTML and then we add some JavaScript inside, right? And then yesterday we learned how to make the entire web page with just JavaScript using React. Basically, we just have a div and then we put all the JavaScript code inside that div. Okay. So now, why would we not want to do this?
So that you can render your images, the page faster and it will run faster. So you only need to run one section rather than continually render the whole page every time an action or behavior happens.
1 point.
That's one.
Yeah. And
Makes cleaner code,
yes.
and that's someone else.
Another thing is like it's easier to debug and maintain our code. Okay, here's the four concepts that we have learned yesterday: components, props, CSS, and render. What's components?
Okay. What's the function do?
Return something.
What's it return?
Option. Then your code.
Yes. A component produces HTML code.
Yes, correct. Props. What's props? Basically, prop is the communication between the parents and the children. When you call a component, you pass props, which means the parent sends something to the children, right? That's it. That's that symbol. CSS. What is CSS?
It's a combination of JavaScript and HTML in a sense, like a merging of the two to make your HTML come out.
Yeah, arithmetic.
Display as HTML.
Yes. And render. What's that? Khoa.
You render the JSS into process.
No.
We can look at it like that right now. Okay. And the second, what rendering is, in a more sophisticated example of rendering is when you update the state of the application and shit changes. For those of you who that have done the finished rock paper scissors, you guys saw that. You know, it rendered again. When you click the button, we change the state, and then it renders again. It automatically follows that pattern from Canvas. Because you remember how in Twitter, in the Twitter one, right? At the end of all our functions, we have to tell it to render, right? But now it kind of sort of just does it based on the state.
Okay, so let's move on to function, props, and state. So, why do we call it React? Just because React to changes. So let's go back to our Twitter app. What control the number of tweets that go up every time you click on the tweet button? We just define a method, a function that do the logic. When you click on that button, actually those are the same thing, but on the left hand side we use vanilla JavaScript. On the right hand side, we define a function for our React app. And in the next slide, you will see the difference between the two. Okay. Okay. The left hand side is the imperative, and the right hand side is the declarative programming. Declarative, yeah, declarative. Imperative programming means just telling the machine how to do it, and the declarative means like you just tell it to do it. You don't care how they do it. Okay.
That's kind of confusing.
Yeah.
Okay, that's super confusing. I'll give you an example. I'll give you a better example. Okay.
Let me do it.
No.
Okay. I spent some time on this. Man.
Okay.
So there's no such thing as a absolute imperative or absolute declarative. Okay. In an example, here, I don't like the example, man. You do it. It's yours, right?
Yeah. Okay, so like imperative programming is like when you tell something what to do every single step of the way. You're like, hey, go out to the store, pick some roses, pick a dozen of them, make sure that they're red. That's imperative programming, right? We got to tell the app what to do on every single step. But the being declarative programming is just like describing certain things, certain situations that like certain characteristics that we want, right? So like be romantic. That's not a simple set. That's that's not telling your boyfriend what exactly to do. It's just saying that you want him to kind of be this way. And if your boyfriend understands that, he might understand like, okay, so romantic things are like roses, maybe. Maybe it's like flowers, or not flowers, but like candies, stuff like that. So anyway, this isn't immediately clear. Just know that like that is a big step away right there now. Yes.
So an example in code would be like running a for loop and trying to do the basic what map does versus just running map.
Basically, when you run a for loop, it's the basic of coding. So you have your logic inside the for loop, right? But when you do a map, you use the method of JavaScript, and you don't care how it runs, how it does. You should get the result, the array. Okay. Another real life example of declarative versus imperative is like, for example, I propose to my girlfriend, hey, marry me. That's declarative. Okay. Imperative means like, hey, we've been together for so long. I love you. Okay. Do you love me? Shouldn't we get married already? Too long, too complicated. Well, that's imperative. Another example, like when you go into a restaurant, you want to find a table, you have to look around and then find, okay, that table is empty. Okay, let's sit at that. That's imperative. Declarative means you get into the restaurant, you just tell the waiter, hey, table for two, please. That's it. So that's the example. Another example in coding, for example, you want to center a string in the center of your page. Okay. Imperative, you're doing like you have to find out the width of your page, the absolute width, and then the absolute width of the string, and you divide by 2, and then you offset it left, offset it right, and you got the center. But you never do that in HTML, right? You just use text align center. That's declarative. Okay. Same thing here. Skip this. We have done this. Okay. So this set state, we actually haven't touched set state yet. And in our next lab, we are not going to use set state because set state is the old way of changing state, update state. We're going to use hook. Set something, set variable, set something, not set state. Okay. But basically, when you set state, after you set state, you call the render function again every time, right afterward. So every time you change some variable, some state of your app, that component that contains that state, re-render, reload. For example, when you click on the like button on Facebook, that little component changes. The like button becomes solid blue. Okay. So don't worry how it works. Just know that's how it works. Declarative. You use it. You don't care how it works. Okay, as Lloyd said, just think of the render function method is the function that you have called multiple times in your canvas game, right?
So set state is, you're saying set state is similar to the render function in R.
Yeah, it does both at the same time. You change the value of your variable, your state, and
So it
then
manages your,
you call the function render again.
Yeah, so it manages your app state and it also will immediately render as well.
Yes.
Instead of having to like say render like we did in our game.
Yes,
So we'd like make a change to our app state, then we'd save our app state, then we'd render.
only that
It
component.
manages to do it all in one quicker process.
Yeah, but it only rendered that component, the component that contains the
Yeah,
state.
rather than the whole app
Yes.
itself.
How do you change state? Okay. Most of the time, you're changing the state in two cases. The first interaction between the user and your app. For example, when the user click on the button or type something or scroll down to a specific area of page, that's how the user interact with your web page. Another case is when you call an API and you get a response from the API. For example, okay, the fetch is okay, the fetch is valid. Status code started 200. It means that okay, you successfully get something from the API, and then you do something.
That code start.
This is just a status for connection between the front end and the back end. 200 means okay, successful. 300 means something wrong. 400 means
400 errors as well.
yeah, authentication something.
404.
Yeah,
It's like those numbers.
correct. Another one is if it's not successful, you would do something else, right? If successful, you show something. If not successful, you show alert that hey, something wrong. For example, something like that. But we will cover this one tomorrow, not today. So don't worry. Okay, that's it. So the next step, we are gonna do the lab. Any questions first? Any questions? It's quite fast, I think.
Is the set state, is that considered a hook?
No, set state here is the old way of changing state.
What is the
Class-based component.
What is the new way?
The new way is you set something else. Set, for example, you have a variable, a state called set term, something like that. Yeah,
We gotta show you guys examples in a second.
yeah.
Okay.
I spent quite some time on this one.
It's difficult, even in English, like the difference between declaring something and being imperative is quite, there's such.
It's like you have never thought about it
Yeah,
before,
you never
right?
think about when you're like giving instructions. Declaring is like saying run at 10 kilometers an hour.
Yeah, you don't care how it
Like,
goes.
run at a medium pace. Like,
Okay. But there's no such thing as absolute declarative. You know?
oh really? You can't
Yeah,
absolutely.
so for something like for complicated things, you have to put in your own logic. That means you are imperatively define.
Steven.
It would be like saying, hey, Ed, go get me a glass of water, versus being like, Ed, I need you to stand up, walk to the right, walk 2 steps that way, to the right, go out the door, get a cup, fill it up with water, bring it back to me. Instead of just saying, hey, can you get me some water?
Yeah.
You guys are gonna see in your components very soon that like we're always just gonna be asking questions of the props and the state. Like if you guys look at your code, we're constantly gonna say, hey, look at like, hey, am I currently doing something? Am I currently signed in? If I'm currently signed in, I'm gonna show this one component. What component? The content, whatever it is. It could be post, it could be the game, it could be anything. But if I'm not currently signed in, then I'll go ahead and I'll show a sign-in form. So like React kind of has this like pattern, like you'll see some of the design patterns. You guys gotta practice a bunch of times, man. You guys are gonna see it until you see it a bunch of times, you know. So the design patterns only become clear with experience, right? Practice it a bunch of times, and you'll start seeing the patterns arrive. So we're gonna start coding.
Yeah, let's start coding.
Demo that app again.
Your app, right?
Yeah.
So this is our final product that our technical lead wanted to build. Okay. You have to do it not exactly like this, but it should work like this. Okay. When you click on this, okay, the computer win, and you have the ring. You lose, you have the red border. What if we have a tie. And okay, change to black. Okay.
Do you have any questions so far, guys? You guys see the behavior, right? Okay, it's very clear what we do. We capture a user's intent, right? We pay attention to a button, and this is important. Why? Because I guarantee you, every single website you guys build in the future is gonna have a button somewhere. Okay, and your boss is gonna want you to pay attention when the user clicks that button, and then you're gonna do something when they click that button. Every one of you are gonna do this. Okay, so we're gonna start very simple. Day one, we're gonna capture a button. We're gonna do something with it.
So I'm gonna do it a little bit different from the lab, from Lloyd's way. Just want to show you how different people do the same thing differently. We start our code. Actually, I have it here. This where we are left up from yesterday. Okay. Let's just delete this. Okay, exactly where we are left up from yesterday. Let's go to the lab. Before we start designing our app, we need to know why and the steps, the requirements, the steps. We have to plan out the whole thing. So to do this, what do we need to have? Like we need the cards, we already have, and the buttons. We didn't have the button. Yeah. So we need the first thing here. Buttons. To do what? Button to record the user choices. Okay. Oh, fuck. Next. What's next? From the button, we got the user, the player choice, right? And then we have to get the computer choice randomly.
You have to generate that.
Yes. Okay, what's the next step? Then we compare them and decide the outcome. And then
Pass the outcome into our.
we have to update our UI to reflect the player choice and the computer choice and the result, the outcome. Okay. I think this is the hardest one if you want to make it short. Update the UI. Okay, let's start. Okay. I'm going to copy the stylings because I don't want to spend too much time on styling. Let's copy it from Lloyd. Actually, I have it here. The next thing is we need to copy the choices here, and that's it. Replace the old choices with the new one.
That's what the choices is.
Okay. What are the choices? What is it? What are the type it is? An object? Okay.
Does this seem different to you guys? Why is the name different than all the other variables that we decide?
Not really.
Because we're never going to change it. This is something that can never change. It's okay to use capitalized variable names if it's something that can never change. So rock, paper, scissors, I don't think you can change it. Unless you guys...
That's kind of like a naming convention. Right?
This is a naming convention, yeah. It makes your code easier to understand.
It could be an array here, but my technical lead wanted it to be an object to make it more difficult for us. Okay, just one line of code more. Okay, the first step we need to three buttons to record our user choice. So put it here. We want to put it right after below our cars, right? Where's the cars? Row here. Let's remove the machine bottom. Okay, another row. And close it. Okay, we need button. rock, paper, scissors, save. Let's start our server. See. What's this?
Slightly different picture.
Hey, yeah, I need some images here. For example, right now, just take the first one, scissor. This is just syntax, how you get the a key value inside of an object. There are two ways of doing it: choice dot scissor or choice, how do you call this?
Square bracket.
Bracket, and you have the key inside. Okay. Oh, not this. Okay, we do have picture and the button. Okay, now we need to record, collect out the user choice by having an on click attribute. Let's say just console log it. Let's define a function here. We need to define a function called, for example, handle player choice. Okay. As Lloyd, he used on player choose. It means on click, on change, on something, right? I prefer to calling it handle player choice. Copy the name of the function, put it in here, same thing here. Okay, now we need to record what's the value of that button. Rock, paper, and then here scissor. Sorry for my spelling, typing. Okay, let's console log it. Okay. Let's click on the button. Okay, we got a rock. We got a paper. Got scissor. First step done. The next step, we need to randomize our computer choice. Okay. How? How do we do that? We already know that there are only 3 choices. We need to randomly pick one of them. Sorry?
Random function that picks a random choice from that choice subject.
Yes.
Math operator.
Does anyone know how to do that? Does anyone know how to write a function that looks at an object and picks randomly from the keys? Huh? I don't know how to do that either, guys. So what's the solution? Yeah, we're gonna Google it.
Why?
Or Quacker write it, I guess. I don't know. It seems to work.
The first is we want to random it, right? Not random. A number. For example, let's call the function random computer choice. And here we put in our choices. Okay? And here we have, let's call it choices. Random choices. Choices here is an object. So we cannot random here, right here. We need to make it an array first. List of choices. Okay, an array, which is this is an array. Object key. This syntax to get the an array of all the keys inside your object. Okay, put in your object choices, and then let's console log it. Here you go. You have a list of 3 choices. Okay, now you need to randomly pick one of them. Computer choice equal to math.random, and then you put in the array dot length because take a number. Then you have to multiply it with the list of choice. This syntax I do it like a couple of times so I remember it.
So you're saying list of choices length is 3?
Length, the length is the length of the array, so it should be 3 now.
Yeah.
So you randomly pick a number and then you multiply it by 3. So you get a 0 something point something, 0 point something, 1 point something, and 2 point something. Okay, now you get the math floor. Okay, let's see how you get. Scissor 0, 2, 0, 2, 1, 2. See, it's only 0, 1, 2, 0, 1, 2. This is the index of our array. This is the index of this array.
So by dividing by 3, that's always going to return something in that section. Like within, you're basically splitting it into thirds and saying, this is within this, then round down to the closest integer within those sections.
No, not really. Select an index, a random index.
Math random takes a number from 0 to 1, yeah?
Yes,
Okay, and then you times that by 3.
time by 3 because I want it to be from 0 to 2.
Exactly, and then you divide by 3 at the end of it. And then at the end of that, you then round it back down using math floor.
I don't divide by 3 here. I just multiply by 3.
Sorry.
It's just comment, and then we get the math floor. Math floor means we get the integer, the integer part of the numbers. Okay, now we have a random index of the list here. Okay, let's console log this. We got the index. Now we get the value of that index. Oops. Wow. Choices. Oh my god.
Computer choice, man. You passing computer choice on line 26. Pass that into computer choice. You haven't used
Oh, what? Sorry, wrong. I did.
What is it? Computer choice is the index.
Okay, now we got rock with a paper with a itching, right?
Yeah.
It does change here. Okay, and then we need to get the value of that object of that key. We got a key now. Here is a key, the key of choices. Now we need to get the value of that key. For example, we return right here. Oh no, we console log it first. Choices. Put it inside here. I know. Comment this line. Okay. Right. You got the exact what?
Keep going, man. Thank you.
But I think we don't want the whole object, or we just want the key. Okay, we got the random computer choice here. We got it. Return Okay. Cons computer choice equal to this. Let's console log. Okay, we have random computer choice now.
On line 28, are you just showing them that you can get the whole object?
Yeah, you can get the whole object. I think too far. I went ahead and then get everything in that object. That's wrong. That's not wrong, but that's unnecessary. Okay. Basically, you only want the key. You only want the string, scissor, paper, or rock. You don't want the whole object right now. Okay. So that's why we need this one. We have the buttons. We have the computer choice. Now we need to decide the outcome. Okay. The last one.
On line 25, what is the object of keys? Is more?
It's a syntax for JavaScript to, for example, to get the array of the keys of the left-hand side of the column
Okay.
in the object.
So
Here.
that makes an array of keys.
Yeah, an array of keys here. Scissor,
How do you
paper,
read
and
that
rock.
format? Like, couldn't you change object to something else?
No, it's this exact format.
It makes an array of strings. The strings contain every key in the object.
In your
Okay.
VS Code, the color would be like blue or something. It's not black like this. I prefer blacks. I don't care about colors. Okay, and then you have computer choice. What next? Decide the outcome. Let's call the function cons decide outcome. Call the function. We put in two arguments. The first is the player choice. The second one is computer choice. Okay, and here we have two arguments. Let's call it B choice and C choice. Okay. How do we decide the outcome now? What's the logic?
If the player chooses rock,
Yeah, if else. But we need to decide what's the first condition. It's a tie. Okay. Else, if B choice equal to, for example, rock, and then return.
no, they compare first.
I want to do a ternary condition here. We return if the player choice is rock and the computer choice is
Paper.
paper. Okay.
Okay, so if the player chose rock and the computer chose paper, who won?
Who won?
Wait, yeah, computer.
Computer won, right?
Rock.
So you return defeat here, maybe.
Let's make symbol lose
Okay, fine. So,
and then win. Right?
so think about it. So if the so we're on line 55. We're already checking to make sure. So this is also a different form of a guard clause. Okay, this is a different kind of guard. Okay, we're saying okay, let's just go ahead and remove one of the options so that now the rest of the code can be easier. So the first thing we check is, are they tied? If they're tied, then we're gonna, everything after that we don't ever have to worry about tied. Okay, just think about it that way. So now we're saying, hey, if the player chose rock and the computer chose paper, who won? Right? So player chose rock, computer chose paper. What should this be? Lose, right? The player chose rock, computer chose paper. If that's not true, then the player has to have won. Right? Because we ignore the case in which they both chose the same thing. That's one thing that Quad did better, may have done better. You guys have to make these decisions as you write code. I know some of you guys looked at what I wrote, right? You guys should compare them, decide who wrote it better. I'm going to think about that in a little bit. So additionally, now we can just do the other one. So if a player chose paper and the computer chose scissors, who won? Yes, so the player lost, right? So they put lose right there. And then there's one more, we have to, obviously do one more.
Scissor and
Wrong.
rock. We have to keep it consistent. Computer always win on the right hand side. The right win against the left. Okay. Okay, now we only have rock and scissor, rock and paper. Okay. Return this or this or this or this. That's it.
Nice.
That's it.
It's nice.
I know. Yeah.
Notice the boy wrote this function outside of the app function using an export. Is there a convention for that, or is it just to save space?
So the reason why I did that, because I wanted to show you guys that like this function does not depend on the state. It can work, it can live outside of the component, right? And that you want to do that as much as possible. When you extract the code outside of a component, it's good for you. It makes the component smaller. So try to do that as much as you can. If you can get the code out to run outside of the component. But you're gonna notice that some functions that we define, they're going to require state. They need access to some state, so you cannot move them out of the component. And we're gonna see that in a second when we introduce our state variables.
Let's call it result, okay? Or outcome. Let's call it result in short. And now we want to render the result on the UI.
Wow, can you console log all three?
Yeah.
Console log all three of them, and make sure you have something that the player chose.
Why?
Player choice.
Player choice, computer choice, and then the result. Okay, let's see it.
Capital.
Oops.
Lowercase on that.
Wait, 38 and 39. 38 and 39.
No.
Oh. Okay, let's scissor. Player choose scissor, computer choose rock, player lose. Paper, tie. Paper again, lose. Oh man.
Let's see. Okay, so let's hit it one time.
Why is that happening then? You see how you got 6 of that?
Random man, random.
Damn.
It's random.
What, you
1 over 3, 33%.
Time.
Yeah.
And you got time.
Has this been right every single time, guys? Think about this. Parsa, if I chose paper and the computer chose rock, who won? I chose paper, the computer chose rock, who won? I know, I chose paper, the computer chose rock, who won? Listen, I choose paper, the computer chooses rock. Who won? I won, right?
I'm rock. Lloyd paper. Oh, the paper one.
Yes, no, wait.
Yeah, but we gotta think about it from the perspective of the user.
This is the player choice.
Hey,
This
let's think
is the
about
computer
this, man.
choice.
Bro, this is easy to fuck up, man, for real.
One
Do
more
it
thing.
again.
Scissor. Okay,
Oh.
it's a tie. Another
Okay,
tie.
I chose scissors. Computer chose scissors. Who won?
No.
Does this say tie? Is this right? All right, come on. Let's do this one more time, guys. Come on.
I got 6 times.
What the heck? Do it again. Okay, I chose paper.
man.
I chose paper. The computer chose scissors. Who won? No, I didn't win, man. I lost.
You won.
I lost,
It's literally
man.
saying it there, guys.
Yeah, that's what I'm trying to say. This is easy to fuck up, okay?
Okay, we're sure that our logic work, our code work, right?
Yeah.
So we need to update our UI to render the result. Where should it be? Between those two? Should make it H1. Okay, and we call it, for example, result. Right here, if we just call result here, you will get an error. Result undefined. Let's see. See? So we have to define it first using hook. Now we learn how to use hook. Cons use equal to use state. Then the value inside. But before it, we need to import our hook library. Use state. Okay. We call the variable name result. The first element is the variable. The second element is the method to change the state. Set result. Okay. And then we give it initial value, default value. Let's start the game. Okay, let's start again. It's right here in the middle. Now we want to update this string, this text to result. Okay, we call it set result to result. Let's see. Time. Oh my god. Okay. Now we want more. We don't just want the result here. We want more. We want the images to change, the styling, the border to change, and the result for each player and computer. Not just the only the lose or win here. So that's kind of tricky. We run this part 3. Do you want me to delete it or just leave it here?
Leave it there.
Okay, okay.
So we're doing the update UI now, right? We've actually figured out some. You use some JavaScript magic, you know, and now we got an outcome. Okay, and the only thing that we paid attention to is what? Is when the user clicks, and then we produce some output writing some JavaScript magic. Now we want our application to react to the update in the state. Okay, so we're gonna look at these variables, and then we're gonna produce more behavior.
Okay, in here we split it into small steps. First is to update images on to reflect choices. Okay.
So which variable needs to change? What lines of code needs to change conditionally now? Let's think about it that way. If we want the images to change, which line of code needs to change?
58, 65.
Yes.
58, 65. So we got to figure out how to make these things change. Okay, let's keep that in mind. That's the objective right now.
So in this function, we already have the player choice changing every time we click the button, and the computer choice also changes. So we need 2 states for computer choice and player choice. Same thing here. Cons player choice, player just player, and set player. Same thing here. And here we set computer. So we want to give it an initial value of noon, just noon. And then here, instead of this, remove this. We have, for some, this component is computer, right? We get the computer dot URL, and here player dot URL. But we don't have the computer or player yet. We don't know what it is. So we need to get this set player, set computer. The player and the computer here should be an object, so we can dot URL here. URL is the key of this object or this object or this object. Okay, so player can be one of them, and the computers can be one of them too. We already have the player choice, the string of the player choice. So we do it like this. Choices, player choice. Okay, and here is choices, computer choice. I should name it with capital C here, but we'll forget it. Okay, let's see. I think that's good. We have to guard against the no value. So computer and then player and then
What does that do?
to guard against the no value, because you're trying to get the value of the key URL here, but by default our computer is no. We can get that key value, so we need to guard. This guarding clause means that, okay, hey, if we already have the computer is not known, then we get it, the value of the URL. If it is known, then forget it.
So the first thing it checks is computer.
Yes, go from left to right.
Yeah.
If computer
If
is not
on
known,
the right hand side.
if it is not known, it means it's
Stop.
true when the number is 1. It's true if there's a string. If it's true if an object has some value inside, it's not undefined or not known. It means true. But here, if you put it a 0 number in here, so it means not true, it's false.
So if you put 1 in there, what happens?
True.
True.
Yeah.
So it will show an image.
True, but you cannot get a key URL
So it will show an
of
error.
1. Yeah. You want to try it?
Yeah, just to see.
Okay, here.
I'll understand.
Well, did you change it?
No error. No.
Okay, because we set it here. It's true, but we set it when we click it. We set it one.
Just refreshing there. Why is no error there?
Because when we click on this, we don't have an image here. See, it cannot get the key. Cannot get the key of 1. Let's console log, for example, console log. What do we change? We change the player or computer? Player.
Change. Computer.
Computer, okay. I have bad memory, man. We change the player.
Oh, you changed the player thing.
The URL. Okay. Undefined. It doesn't throw an error, just undefined. Okay, remove this line.
Yeah, you can take that.
Okay, we guard against it. We already have it. Now check scissor. Okay, we pick scissor here, and the computer pick rock. Rock is here. That's good. We pick rock, and the computer pick paper. Good.
You're not winning today.
Oh man, really? Yeah, I did.
There you go.
So it works as we expected, right? Okay, next step, update the outcome
Oh,
for each, update the outcome. Actually they are at the style and outcome for each card, right? This tricky part. Yeah.
So we can think of the set state as like it's like a variable and a function in one, almost, right? You're setting a variable that's talking to a function that's updating that variable.
Yeah.
Okay.
But there's a lot more complicated things going behind.
It's interacting with the virtual code, I'm sure.
Yeah.
Things like that. Okay.
So just basically, the first one is the variable, and the second one is the method. You want to change the value of that variable, and then you call this
Okay.
the render again. That's it. That's declarative.
Right.
Declarative.
Yeah.
Okay, now we got the images, we got everything. Now we need to update the styling. Depends on the outcome. Here comes the tricky part. We got it. we don't want to hardcode it true or false. We want to hardcode it. For example, let's pass some color. Okay. Call it glass color. And then we define a function, a method calls glass color. I should change it. Should I name it like this? Okay, keep it. And then we pass that function. Basically, I want to send a class name inside here instead of using this. Okay. I want to send something called class color in here. I want to do any condition check. I just want to send the, for example, red is for losing, green for winning, or black for a tie. Okay, I want to directly send it to here. Where were we? Okay. So we need to call it. We need to return something. Do condition check if, and then return something, right? It's kind of like something like this. Something like this function. Oh no, this one.
Yeah.
If something, then return black. If something, then return green. If something, then return blue. Okay. But before that, we need to give something like because we have two component choice char, two component. We don't know, the computer doesn't know which one is which. We need to give it a name. For example, this one is computer. First one is computer. Second is player. So this function understand. Okay, for computer I will return something else. For player we will return something else. And the second result. Yes.
Why we need to put a function inside another function?
This is called anonymous function. I don't want to go like how do you say it? Anonymous function. Want to go against.
Say again.
He asked why we want to have another function inside a function.
This is a more complicated problem that you guys are going to run into later.
Yeah, I want to prevent the bugs. For example, you got into infinite loop. It automatically call that function every seconds. You cannot stop it. It's automatically called. So that's to go against it. We have to make it an anonymous function, or you have to bind it to our component called app, which is more complicated thing. So this easy syntax. Okay, we got the first argument is the computer. I call it a target, and then the second one is result. I call it rest for short. Okay. If rest equal to for example tie, then we return what?
Black.
Black. Yes. Else if rest equal to win. Win here means the player win. Return target. If the target is player, we return what? Red. I mean green. Sorry. we win. We're winning. But here in our app.js, our technical lead call it winner and loser. It's not red or green. So we need to change it to winner. And then else loser. Else if. You can do it different from me, because this is our own logic. You can pick any way you want. Like if you think your way is better, your method is better, do it. Lose. Then return target. Loser. Winner. Okay. Save. Actually, you have to return something else, but blah blah blah. Save it. And let's see. We got the pass the class color. The pass class color. It looks okay to me. Remove this one. We haven't had it. Yes. Okay. Hi. Now it doesn't change. Why? Console of props dot class color. Let's see what's wrong. Oops. Oh, we passed the whole function, man.
I was wanting to say you don't need to do that. You just call it right away.
Yeah, we passed the whole function. Just remove this. It's not on click.
So now we don't have a function inside.
The function will evaluate immediately. Can we go back?
I was wrong because I remember it's like an on click. On click is a function. This one is not. It's just to pass a props. A props can be anything, but right now we only want to pass the string black, winner or loser. That's it. I was wrong. Sorry. Okay, here, click. Yay! It changed. I win.
Well done.
Yay! Thank you.
Time.
Man, so many times. Okay, the next step we want to render the result for each card here. Let's make it right here. I don't know why he have a lose, he have won. How do we do it?
We want to look at our result, put it a property into the H1 or H4 tag in our choice class.
So we already have different tie, winner or loser, 3 different strings for our components. So we need to do a condition check. Logic incoming. Okay, first we need to do if. We want to call it results. Okay. I love result. Okay, outcome.
Player result or something like that. Because it's not just the result.
No, it's not player. It's both.
Yeah, no,
it can be
they're
computer
both
and yeah.
Computer and
Yeah. So you just call it outcome, and then you call outcome here function, and you return something. Okay. If. Oh my God! If again. If props dot class color equal to black. Type. Else. Yeah.
Guys, what we're doing right now is that, like in life, when you update one thing, you can make assertions about other things, right? And I know that seems complicated to think about, right? So for example, who here knows how many people live in Vietnam? How many people live in Vietnam? 93 million? Something like that? What do you think, Hai? I know, but I'm trying to say like around. Let's just say around, right? About 95 million people. Does anyone disagree? Who here agrees? Right? About 95 million people live in Vietnam. So we're going to think about one piece of state that changes and how it affects other pieces of state, right? So if all of us packed our shit and we moved to America or France or some other country, what would happen to the population of Vietnam? Yeah, it would go down some, right? So that's what we're doing right here. We're looking at a piece of state, and then we're going to make another assertion based on that piece of state.
Okay. Oh shit, it's not mine. It's my sister. Okay, sister lose, computer win. Okay, again. Computer lose, player wins. Perfect. Right. Remove this. We don't need the logic incoming. Okay, what's next? We've gone through all of this, I think the last filter we need to have the result, the list of results history. That's actually very easy to do. We need
So easy.
a variable that store a state that store on the records. That's it. And how do you call it?
A variable within our state to store the.
Yeah, you call it state history. Okay, and then you set history. Use state. Initial value is
No,
empty array.
I just empty the array.
Yeah, empty array.
So there you're defining that the history will become an array.
Yeah, right here. You change the state of history right here. After you get the outcome, you saying it history dot push what? Guess.
Okay.
Push what?
The result.
Yes. Then you have to render the history to the UI. Where should I put it? Choose, guys. I'm so bad at designing and UI UX.
Can we
Choose.
see your page? We'll tell you where.
Where you want to see it? Right here? On the right hand side? Oh, forget it, just make it here. Okay, where's our button? Right here? We make another div. Okay, now we're gonna run a map here. We have to render our results. Mapping. If where is it? History dot map. This is a method. What should be inside? What's argument? Another function. Okay, like this. Let's see. History.map is not a function. Why?
It's because when you set it, you return something else. You gotta push it first, and then you set it.
Yeah, that's why I don't like push. There's another syntax, guys. A beautiful syntax. Yes. And then what? Result.
What does that mean?
You keep the old one and you add another element inside.
What was it? What was in the history the first time the app loaded?
An empty array.
This is an empty array. The first time it's run empty array, and then you add another element after it.
This takes two arrays and produces one array. That's all it does.
Right. I think this is the most beautiful way to do it.
Show me an example. Show me an example.
Of what?
Do it in Quokka. Do it in Quokka.
I don't have Coca.
Fine. Do it in Chrome. Imagine you guys have an array and you want to have two array. You guys have one array and you want to take one more element and put it inside of there. And you want to create a new array as well.
Okay.
So how can we add 3 there to that array? Okay, so now this is in more advanced JavaScript. You want to explain?
Mutable object.
Yeah. So in the near future, you guys are going to be learning about mutable objects and like what it returns and etc. But right now, we need to create a new array and stick a 3 in there. So this works.
I cannot change it.
Look at A now.
What do you mean for? For is
Look at A.
What's the length of the array?
I did it 2 times.
Yeah. So that will return how long the array was, but we need an array still inside of our history, right? So now if we can produce a new array by doing what? By doing the brackets.
A equal to brackets dot a comma
6.
4. What do you expect to see?
5 items in our array, the last one being 4.
Correct.
Don't worry about this now, guys. This is called a spread operator. Spread. S-P-R-E-A-D. Okay, you guys will learn about this later. You'll see other examples of how to use this.
But this way, it saves you a lot of one line of code.
Takes one line.
Yeah, it saves you one line of code.
All right, so let's see if you fixed it. Come on.
Okay. L. Oh my God.
That's all you're putting in there.
I forgot the curly braces. Loose. It's tie. It's another tie. It's another tie. Holy shit. See? Exactly what we want. Now your job is to style it. Make more features. Okay, that's it.
Whose result were you showing? Your result each time there.
Yeah, this one. The history is this one. You get this one. You put it into an array.
Okay, so that's the assignment for today, guys. Your job is to build this. And for those of you who did it yesterday and found it's easy, I want to now add a new column that says percentages of each choice. Okay? Introduce, and I'll go ahead and give you a hint right now how to do that. If you guys want to know, I'll show you the simplest way you can figure out what results. Okay? So, whenever we update our game history here, I don't want you guys to just stick in the result right there. Let's just produce a new object. We say const results, new result, and then we'll say that's an object. Then we're gonna say winner is equal to what? How can you know who won? Let's just say player choice. Let's start small. P choice. What is that? Player choice. And then C choice is computer choice.
Yeah.
And result is result. And then we're just gonna take this object and we're gonna stick it in there. And let's just look at our history afterwards.
Fix the
What do I need to fix?
render,
Put it in there.
the map,
Oh, yeah.
disable it.
Say result right here. So now we're gonna look at the result still. Now the objective becomes what? Let's look at our history. Oops. Okay, we're gonna do something.
Okay.
Look at our history, guys. Our history has become more sophisticated than what we had yesterday, right? For those of you that finished already. And now it's a list of objects. And now we need to look at this list and we can make certain assertions, right? How can we determine the percentages of papers and the percentages of rocks off of this? You can. I promise you, you can. If you know JavaScript, you can do that. Okay? So we need to figure out what percentage of the time the scissors were chosen for both players. And if you guys want to get more complicated, let's show percentage of scissors for computer, percentage of scissors for a player, and then percentages of scissors total. Okay? This is where your creativity comes into play. You guys can do this.
Just think of it as baccarat in casino.
All right, do you have any questions, guys?
What's baccarat?
Again.
I'm kidding.
Are you? Really?
Also, I want to see if one of you guys can figure out how to just not let the user start the game until you sign in. Can anyone do that? Does anyone have an idea? I'll show you right now. Fuck it.
Let them do it. Why are you showing everything?
Because a lot of them got done already. All right, fine. You guys just keep going. We'll do that later. We got more practice to do that one later.
Let them think.
Okay, fine. Good job, man.
Where's the video? No.